Hey there, construction buddies. Ever wonder what keeps those massive skyscrapers standing tall, or why some buildings look sleek and modern while others have that classic, sturdy feel? Well, today, we're diving into the fascinating world of building structures. We'll be breaking down all the key parts, from types and forms to the primary and secondary elements that hold it all together. And don't worry, we'll keep it fun with pro tips, hacks, and even some real-world examples. Ready to build up your knowledge? Let's get buzzing. When we talk about building structures, the type tells us what kind of load the building can handle, while form is about the shape and style. Structural types range from load-bearing walls and ancient temples to today's high-strength steel frames and city skyscrapers. These types decide how weight is distributed, whether the building can handle wind and earthquakes, and how flexible or rigid it might be. Forms, on the other hand, influence a building's appearance and efficiency. Domes and arches, for instance, spread loads across their curves, making them super strong and visually impressive. Think of the Pantheon in Rome or stadium domes today. Geometric shapes like triangles add strength, which is why trusses, which are triangular frameworks, are widely used in bridges and roofs. Pro tip: when choosing structural types, consider the environmental factors and loads the building will face. Opt for forms that not only look great, but also perform well under pressure. Case study: in Tokyo, the Tokyo Skytree utilizes a triangular base and transitions to a circular frame as it rises. This design improves stability during earthquakes, making it one of the most resilient structures globally. Let's dive down below the surface, literally. The substructure is the part of the building that lies below ground level, mainly foundations. It's like the building's feet, giving it a sturdy footing. The substructure distributes the building's load into the soil, preventing sinking, tilting, or worse, collapsing. Foundation types vary based on soil and load requirements. Deep foundations, like piles and caissons, reach way down to strong soil layers or bedrock. Shallow foundations are used for lighter structures and spread out close to the surface. Pro tip: always perform soil testing before deciding on a foundation type. It's one of the most critical steps in ensuring safety and longevity. Case study: Dubai's Burj Khalifa, the world's tallest building, relies on a deep foundation that extends over 50 meters into the ground, helping it withstand the immense weight and Dubai's sandy soil. Now, the superstructure is everything above ground: walls, floors, and roofs that form the main body of the building. This part is crucial because it's where people live, work, and play, and it's also exposed to the elements. Superstructures can be rigid, like concrete or steel, or flexible like wood, depending on the function and design goals. The superstructure supports its own weight as well as external forces like wind and earthquakes. Tall buildings often have reinforced concrete cores or steel frameworks to give extra strength and flexibility. Pro tip: when designing a superstructure, balance durability with flexibility to handle forces like wind and temperature changes without cracking or buckling. Case study: the John Hancock Tower in Chicago has a famous steel framework that allows it to sway slightly in the wind, making it resilient and less likely to crack under pressure. The primary elements of a building structure are the skeleton, columns, beams, and load-bearing walls. These elements bear the load, just like our bones hold us up. Columns support vertical loads, while beams handle horizontal loads, forming a sturdy framework. Secondary elements, like walls, partitions, and floors, are the flesh. They don't carry the weight of the building but provide shape, space, and functionality to the structure. Together, these elements create a cohesive structure that's both strong and functional. Pro tip: for cost-effective construction, use prefabricated secondary elements. They save time and minimize errors, especially in large projects. Case study: a popular secondary element approach is used in modular construction, where walls and partitions are manufactured off-site and then assembled on-site. This reduces build time significantly. Finishes are like the final coat of paint on a masterpiece. They cover structural components, giving the building aesthetic appeal and protection from weather. These include plaster, paint, tiles, and more. Finishes can also be functional, like soundproofing for walls or slip-resistant flooring. Finishes should reflect the building's purpose. For example, hospitals often use easy-to-clean, sterile finishes, while corporate offices might opt for a sleek, professional look. Pro tip: always prioritize durability and maintenance in finishes. Choose materials that age well and can be easily repaired if damaged. Sleek, professional. Case study: many green buildings use low VOC, volatile organic compound, finishes to ensure better indoor air quality, reducing health risks associated with chemical exposure. Case study: many green The external envelope, or building skin, wraps around the entire structure, protecting it from the outside environment. Think of it as a shield, keeping out rain, wind, and extreme temperatures. It's made up of walls, windows, doors, and the roof. Besides protection, the envelope also controls energy efficiency by regulating airflow, insulation, and natural light. High-performance envelopes can significantly reduce energy costs by minimizing heat transfer, helping the building stay cool in summer and warm in winter. Some modern buildings even feature double-skin facades, adding extra insulation. Pro tip: opt for energy-efficient materials for the building envelope to lower long-term utility costs and boost sustainability. Alright, construction buddies, we've journeyed through the whole building, from the ground up. Understanding these structural essentials is like knowing the secret ingredients in a recipe. It helps you appreciate why every part matters. Whether you're planning a build, studying architecture, or just curious about what makes buildings stand strong, these insights are the backbone of any successful structure. Remember, building isn't just about putting up walls, it's about creating spaces that last, serve, and inspire. Catch you in the next video. Happy constructing!